Hey, math students. I got this question sent to me on Facebook by Miriam, so let's take a look. It says, multiply, write your answer in simplest form. And honestly, I feel like those directions were a little obvious. We didn't really need them because I can tell that this is something where I need to multiply. Nobody needs to tell me. Let me show you how I can tell that. I see that this ugly number, as ugly as it is, negative 6 square root of 10, is shoved up against these parentheses here, indicating that it is multiplying by every number or term in those parentheses. Okay, so definitely I'm multiplying, and of course, as always, when I'm working with algebra, unless somebody tells me otherwise, I want my answer in simplest form. I'm going to do all the math that I can do and then walk away. So that being said, usually when we're simplifying, we follow what's known as the order of operations. We deal with our groupings first, then our exponents, then our multiplication, division, then our addition, subtraction. So you might be wondering, well, then why aren't we starting in the groupings? Why do the directions say multiply when in the groupings I have a subtraction? Well, if you look at that grouping there, that's not math that I can do. I can't actually simplify that. I can't actually do the subtraction. You know, I can't take a radical 7 square root of 15 away from a whole number like this, 7. We just don't do that. It reminds me of like when you have x's, like you wouldn't do 7 minus 7x because they're not like terms. So we can only add and subtract the same kinds of things. So really, yes, all we can do is this multiplication they've told us to do. So let's go ahead and do it. When you go to multiply with radicals, students freak out like they don't know what to do. But we're going to multiply like we always have. And again, it really reminds me of when we multiply, like 7, or let's say it's like 6x. Imagine if I was multiplying like negative 6x times 7. A similar situation. Well, what would I do? I would multiply together the numbers, the coefficients, in this case negative 42, and then I would just tack on the x on the backside. And we're going to do the same thing here. We're going to multiply together the two whole numbers. Negative 6 times 7 is negative 42. And then I'm just going to tack on the only radical I have. So square root of 10. And I've done the multiplication there. Okay, now let's do the second act of multiplication. I'm going to take this entire thing, so negative 6 square root of 10, and multiply with that thing, negative 7 square root of 15. Okay, make sure you consider it signs with them. That's negative 6 square root of 10, and when I'm multiplying, I consider that to be negative 7 square root of 15. So a negative times a negative is a positive. And then once again, I'm going to do whole number times whole number. So 6 times 7 is 42. And then I'm going to do square root times square root. If they're both under radicals already, I can totally do that. And so I end up with the square root of 150. Cool. And here it looks like I'm done. Like, yay, I multiplied. But this is why they gave you those kind of duh directions. Notice how it says write your answer in simplest form. Now, don't get fooled here. I can't do this addition here. So that's not how I'm going to make this any simpler. Once again, we can only add and subtract the same kinds of things. And this is negative 42 square roots of 10s. But this is 42 square roots of 150. They're not the same kind of thing. So I can't actually do the addition. So what can I do to simplify this? Well, what students don't realize is even when something's not a perfect square, like for example, 10 is not a perfect square, there's no way to multiply a number by itself to get to 10. 3 times 3 is 9, 4 times 4 is 16, 10's not a perfect square, but even when a number is not a perfect square, sometimes it contains a perfect square within it. So what I'm going to do is I'm going to look at these two radicals to see if I can simplify them. So let's look at 10 first. Let's see what factors it's made of. I'm going to use my favorite tool to do that, a factor tree. And one way to think about 10 is made of two factors multiplying 2 and 5. Now, you can see with 2 and 5, I have no repeating factors. I have no perfect squares. I would have to have the same two numbers multiplying in order for it to be a perfect square. So that sucker is not going to simplify anymore. However, that's different from 150. Let me show you what I mean. Again, I'm going to break down 150 using a factor tree. And remember, when you're using a factor tree, it doesn't matter which times tables you use. You just got to keep breaking. So like, for example, I know 150 is 15 times 10. And 10, like we said, is the same as 2 times 5. 15 is the same as 3 times 5. And look what I found hidden inside the number 150. Even though 150 itself is not a perfect square, it contains a perfect square. It contains 5 times 5. And so what I can do is I can simplify that part of the equation, that part of the expression. I can pull the 5 out of the square root symbol of the 150. Now you might be saying, well, what's left? Well, whatever's left is those factors I haven't used up, the 2 and the 3. Now, we pulled them apart through division. We're going to put them back together through multiplication. They're factors. They multiply. So 2 times 3 is 6. So what I just found out is that this portion of the expression, the square root of 150, simplifies to 5 squared root of 6. Now, how do I deal with that when there's already a 42 out here? You're like, well, what in the world? Well, what that basically means is the whole numbers, just like the numbers on the inside of the radical, the numbers on the outside of the radical multiply together. So you're going to multiply that 42 with that 5, and then just tack the square root of 6 on the backside. So I get negative 42 square root of 10 plus, let's see, what is that? 210 square root of 6. And again, I'm stuck now. There's nothing I can do. I can't simplify the square root of 10. It has no repeated factors. I can't simplify the square root of 6. It has no repeated factors. And I cannot do this addition because these are not the same kind of thing. I'm done. This is simplified. Now, just a note to you guys who are like overwhelmed, saying, oh my gosh, that was a really challenging problem. This is not generally the style of simplifying radical expressions that I see on the GED. So this is a little bit more complex. However, it does definitely come up in, like say, college algebra. And this same skill, even though it looks a little different, comes up in a lot of different contexts in college algebra, in Algebra 2. We're going to use it as we start to see imaginary numbers. So it's worth it to master this skill, even though it's a little weird and time consuming. All right. If you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer them. Thank you.